The solar system only feels normal because it is the pattern you grew up with. You were taught to see it as orderly. Small rocky worlds near the sun, giant planets farther out, frozen debris at the edge. A system so familiar it starts to feel inevitable. But the closer you look, the less this architecture resembles a clean design. Mars is underbuilt, the asteroid belt is disrupted, Venus rotates the wrong way, Uranus looks knocked over. The outer solar system is full of trapped, scattered, and displaced bodies. This is not what a calm beginning looks like. It looks like a system that was reworked and then made to look stable again. From a distance, it still knows how to perform normality. 4 small rocky worlds close in, 4 giant planets farther out.
Before we begin, if you enjoy thoughtful space videos like this, please consider subscribing. I truly appreciate your support, and it helps this channel continue making more videos like this one.
Belts of leftovers, moons tracing careful paths around their primaries. It is easy to flatten that layout into something simple and forget how extreme the actual scale is and how easily instability can hide inside something that looks orderly from far away. Mercury huddles so close to the sun that its year flashes by in just 88 days. Neptune drifts so far out that sunlight there is reduced to a weak pressure from a distant star. Between those limits lies an arena of gravity, resonance, and ancient traffic. This is not just a set of planets separated by empty space. It is a dynamical system, and dynamical systems keep records. Not written records, but orbital ones, distribution records, tilt records, debris records. The solar system kept the evidence. We just got used to seeing it every day. That is what familiarity does. It turns a strange structure into background.
It makes a disrupted architecture feel natural, simply because it has been hanging above us for as long as human memory can reach. The first reason it feels normal is also the most misleading one. It is ours. We did not discover the solar system as one option among many. We discovered other systems after growing up inside this one. That reverses the logic. Instead of asking whether our architecture is typical, we unconsciously treat it as the reference design. Then we notice exoplanets doing outrageous things and call them strange. Jupiter-like planets skimming close to their stars, resonant chains packed tightly together, giant planets where we do not expect them, super-Earths crowding inner systems. Yet if you step back and look at our own arrangement without the comfort of familiarity, it is full of discontinuities that are difficult to call neat.
The planets are not evenly spaced. Their masses do not scale smoothly. Their compositions divide sharply. Their moons tell conflicting histories. Their outskirts are littered with bodies that look less like untouched leftovers and more like material that was shoved, stranded, trapped, or thrown outward. That inner-outer divide is one of the clearest warning signs. Close to the sun, the planets are rocky, dense, and relatively small. Then comes a rupture. Beyond that boundary, the system is suddenly dominated by giants wrapped in deep atmospheres, carrying huge inventories of gas and ice, orbited by miniature systems of their own. Some of that divide is expected. Temperature plays a role. Materials condense differently at different distances. The early sun heated the inner region hard enough that volatile compounds struggled to remain solid close in, while farther out, ices could accumulate and help planetary cores grow faster. But that only explains why planets might differ.
It does not explain why the architecture feels so starkly cut, why certain masses look starved, or why the leftovers between worlds look disturbed instead of simply unfinished. Mars is where that discomfort becomes obvious. If the inner solar system formed from a broad disk of material that gradually built rocky planets, Mars should have had the chance to become much more than it is. Earth and Venus dominate the inner region. Mercury is odd for its own reasons, but Mars is the planet that looks stranded between possibilities, too far out to compete with Earth and Venus, too small to fit comfortably into a simple growth sequence. In context, it is underweight, almost like a world that began forming in a richer neighborhood and then ran out of supplies. It does not feel like a complete answer. It feels like a planet stranded in the middle of an interrupted process.
That is one clue, because the distribution of mass in the inner system is one of the clues that the young solar system was not left alone long enough to settle into a smooth arrangement. Something truncated the material reservoir. Something limited what Mars could become. Then there is the asteroid belt, a region that popular imagination once turned into the remains of an exploded planet, because the reality is stranger. The belt is not the grave of one world torn apart. There is nowhere near enough mass there for that explanation to hold. What it looks like instead is a zone where planet formation was interrupted, stirred up, and prevented from finishing. The asteroids are diverse in composition. Some are rocky, some are rich in carbon. Some show signs of forming under very different conditions. That diversity is part of the clue. The belt behaves less like a single broken object and more like a mixed population, a collection of bodies that were never allowed to merge into a planet because the gravitational environment kept exciting their orbits and turning mergers into destruction. Even before deeper models enter the picture, the individual planets keep adding to the sense that this system did not emerge in a clean, symmetrical way. Venus adds another fracture to the pattern. Its day is longer than its year, and its spin is retrograde, meaning it turns the opposite way from what most people casually expect. There are plausible ways to get there. Major impacts, tidal effects, long atmospheric influence, but none of them make Venus feel ordinary. They make it look like a planet with a history.
If you've been enjoying the video so far, subscribing is one of the best ways to support the channel. I'm genuinely thankful to have you here, and your support helps make more videos like this possible.
Uranus is even harder to treat as a casual variation.
Its axis is tipped so dramatically that the planet looks knocked sideways, as if some ancient event left it rolling around the sun. Whether that tilt came from a colossal impact or a sequence of interactions, it reads as history, not as decorative weirdness. And the moons refuse to fit a single family pattern. Earth's moon is unusually large for the planet it orbits, so large that its origin points strongly toward a violent impact in Earth's early history. The regular moons of Jupiter and Saturn look like products of miniature disks around giant planets. Then Neptune has Triton, a large moon moving backward relative to Neptune's rotation, which is a huge red flag. Bodies formed neatly in place do not usually end up on retrograde paths like that. Triton looks captured, likely a former Kuiper Belt object seized by Neptune's gravity. Capture on that scale is not gentle. It reshapes the system it enters.
Again, the point is not that one odd moon exists. The point is that the solar system repeatedly prefers histories that involve disruption. The farther out you go, the more that disturbance becomes impossible to ignore. Beyond Neptune lies the Kuiper Belt, and beyond the classical Kuiper Belt lies a population of scattered bodies on elongated, tilted, and deeply peculiar orbits. This outer debris field is not a quiet decorative fringe. It is a fossilized, dynamical archive. Some objects are locked in resonance with Neptune, completing specific numbers of orbits for every set number of Neptune's own. Pluto is the famous example, protected by a 3:2 resonance that keeps it from colliding with Neptune despite the crossing geometry of their paths. Resonance like that is often a signature of migration. A planet moving through a disk can sweep bodies into resonant relationships, trapping them as it goes. Structure can be sculpted by motion. Resonance is one of the ways the solar system tells you it was rearranged, not merely assembled. Once you see those clues together, the question changes. It is no longer why this one planet acts strangely, or why this one belt is underdeveloped. The real question is whether all of these irregularities can be read as parts of one larger reconstruction. Modern planetary science increasingly treats the answer as yes. The solar system looks suspicious because it carries connected stars. Its present layout is not just where things ended up after quiet formation. It is what remained after major bodies moved through one another's neighborhoods, exchanged angular momentum, destabilized smaller populations, and reshaped the disk they were born from. One of the clearest reconstructions for the inner system is known as the Grand Tack. The name comes from sailing. A tack is a turn.
In this model, Jupiter did not simply form and stay where it is. It likely moved inward through the gas disk early in solar system history, drifting toward the Sun. That alone would have been a profound disturbance, because Jupiter is not just another planet, it is a gravitational machine. As it moved, it would have scattered and depleted material in the region it crossed, truncating the disk from which the rocky planets were forming. Then Saturn, forming later and migrating as well, entered into a relationship with Jupiter that reversed the motion. The two giants moved outward together. In other words, Jupiter may have plunged inward and then turned back. That single reversal helps explain several things at once.
If the material available to build terrestrial planets was cut off around the region of present-day Mars, then Earth and Venus could still grow large in the denser inner zone, while Mars would be left as a starved remnant, a planet-forming embryo that never had enough nearby mass to catch up. The asteroid belt in this picture also makes more sense. Instead of being the ruins of a destroyed world, it becomes a repopulated boundary region, seeded by bodies from different parts of the early solar system after Jupiter's migration stirred and redistributed them. The Grand Tack does not solve every detail, but it transforms Mars and the asteroid belt from isolated annoyances into expected consequences of giant planet movement. Then comes the outer system, where another reconstruction takes over. The Nice model, named after Nice in France, deals with a later phase of instability among the giant planets. In its broad form, the idea is that the outer planets did not begin on the exact orbits they occupy now. They formed in a more compact arrangement, surrounded by a massive disk of icy planetesimals. Over time, gravitational interactions between the planets and that disk caused migration. Jupiter shifted slightly inward. Saturn, Uranus, and Neptune moved outward. At some point, resonance crossings among the giant planets destabilized the architecture, triggering a phase of scattering. Neptune pushed into the planetesimal disk. Vast numbers of smaller bodies were thrown inward, outward, or entirely out of the solar system. This helps explain why the outer debris looks stern instead of serene. It helps explain resonant Kuiper belt populations, scattered disk objects, Trojan companions sharing giant planet orbits, and the broad fact that the outskirts preserve evidence of reshaping rather than simple leftovers frozen in place. The model has changed over the years as data improved, and not every version makes the same claims with the same strength. That distinction is important. This is reconstruction, not mythology. But the central result survives. Giant planets do not need to stay put, and if they move, they can rewrite the rest of the system on a vast scale. And once you accept that, the solar system stops looking like a calm arrangement of finished worlds. It starts looking like a place where timing shaped outcomes, where one migrating giant could change the fate of every smaller body caught in its wake. Put the grand tack and the nice model side by side, and the solar system starts to read coherently. Early migration among the giants helps sculpt the inner system, starving Mars and disturbing the asteroid belt. Later instability in the outer system helps populate resonances, scatter icy bodies, and produce the distant architecture we observe today. Add giant impacts to that already active picture, and the worlds themselves begin to fit. Earth's moon, likely born from collision. Uranus, tipped into extremity. Venus, perhaps pushed into unusual rotational evolution. Triton, captured into Neptune's system like an intruder that never belonged there. The details differ, but the pattern does not. This was not a still life. It was an environment where large bodies moved and smaller bodies paid the price. That is why the solar system's asymmetries are revealing. Uneven spacing is not just aesthetically untidy. It can reflect histories of migration, resonance capture, and depleted feeding zones. Contrasts between neighboring planets are not just trivia. They are clues to different growth environments and different interruptions. Debris belts are not just leftover clutter. They are the places where formation failed, or was halted, or was later rewritten by the gravity of larger survivors. Tilts, retrograde motions, resonance locks, and captured bodies are all versions of the same message.
The solar system still carries the structure of what happened to it. The emotional trick is that familiarity makes violence hard to see. We think of the solar system as settled because we inherited the quiet version. We did not witness Jupiter moving through the young disk. We did not watch Neptune stir the outer debris. We did not see the impact that made the moon, or the event that tipped Uranus, or the capture that gave Neptune Triton. We see the cooled result. Stable now does not mean born stable. Surviving is not the same thing as having formed cleanly. And that may be the clearest way to reframe the entire architecture. The solar system is not best understood as a perfect blueprint for what planetary systems should look like. It is better understood as one successful outcome among many, carrying a readable record of disruption.
Its calm appearance is real, but it is late. Its symmetry is partial. Its order is repaired order. When you follow the clues from Mars to the asteroid belt, from Venus to Uranus, from Triton to Pluto's resonance, from the Kuiper belt to the giant planet's reconstructed motion, the anomalies stop competing with one another and start confirming one another. They are connected signs that the system was reworked. So the solar system does not look wrong because nature failed. It looks wrong because we arrived late, after the violence had settled into structure. What we call order is real, but it is not original. It is repaired order. The planets are not simply arranged around the sun.
They are arranged after migration, collision, scattering, and loss already left their mark. And once you see that, the solar system stops looking like a clean design. It starts looking like a survivor, not untouched, not inevitable, just the version of home that remained after everything else had been forced to move.
Thank you for watching and for spending your time here. Your support means a great deal to me, and it helps this channel keep creating more carefully made videos for you. I will see you in the next one.